In this lesson, we are going to be tracing through the least significant digit radix sort algorithm. Here is a quick review of the algorithm. Here we have an initial data set. Within the data set, there are two numbers that are 743, labeled with an A and a B to track their relative order throughout the sort. A and B are not digits and do not need to be considered when sorting. Additionally, in this example, we are only sorting positive values. Therefore, we are only going to use buckets 0 to 9. However, you will need to account for negative numbers in future assignments. On the first iteration of the loop through k digits, the data is sorted by the ones digit first. Notice how the digit is underlined in each value of the array. Entering the inner loop, we begin with the first element in the array and place 17 in the 7 bucket. 743 is placed in the 3 bucket, 672 in the 2 bucket, 780 in the 0 bucket, 917 in the 7 bucket, and recall that the buckets are acting like queues. 743 in the 3 bucket, 623 in the 3 bucket, 288 in the 8 bucket, 432 in the 2 bucket, 281 in the 1 bucket, and 76 in the 6 bucket. The loop terminates and moves to the next statements in the procedure. The index for the array is set to 0. We enter the next loop to empty the buckets and begin with the 0 bucket. In this process, we remove from the buckets and put the data back into the original array, overwriting the data that is there. We empty the 0 bucket, the 1 bucket. Notice that the 2 bucket is acting like a queue and the data is removed from the front of the queue. Bucket 2 is empty and we move on to bucket 3. We begin to empty bucket 3 and the values 743, 743, and 623 are placed back into the array. Buckets 4 and 5 are empty and will be skipped over in the while loop. We empty bucket 6, bucket 7 is emptied, and finally we empty bucket 8. Bucket 9 is skipped over in the while loop, and the bucket removal loop ends. The algorithm then returns to the top and processes the data for the next digit. Let's take a moment to examine the array after one iteration. It may not look like anything was accomplished, but take a closer look at just the ones digit. They are all sorted by this digit. On the second iteration of the loop through k digits, the data is sorted by the tens place. Notice how the tens digit is underlined in each value of the array. Since the algorithm adds and removes from the buckets in the same order, values that have the same tens digit will be sorted by the ones digit and the tens digit in that bucket. You will see how this propagates through the iterations to allow us to fully sort the data. Looking at the tens place, we will place 780 in the 8 bucket, 281 in the 8 bucket, 672 in the 7 bucket, 432 in the 3 bucket, 743 in the 4 bucket, 743 in the 4 bucket, 623 in the 2 bucket, 76 in the 7 bucket, 17 in the 1 bucket, 917 in the 1 bucket, and 288 in the 8 bucket. The values in the 8 bucket are sorted in order by the ones place, with 80, 81, and 88. Now we enter the loop that empties the buckets. Bucket 0 is skipped over since it is empty, and we move on to the 1 bucket. We remove 17, 917, then 623, 432, 743A, and 743B. Buckets 5 and 6 will be skipped over. 672, 76, then 780, 281, and 288. This ends the removal and the second digit iteration. Again, this may not look sorted until you examine the tens and the ones digit. You will notice that the array sorted by the tens and one is in order. We begin our final iteration and sort the data by the hundreds place. 17 does not have a hundreds place, so it automatically goes in bucket 0. 917, 623, 432, 743, 743, 672, 76, 780, 281, and 288. We now enter the loop to empty the buckets. Watch as we empty the buckets and all of the data from the buckets is copied back into the array. The array is now fully sorted.